Hello, welcome to another session of Engineering Economics. Today we're going to solve a couple of problems with single cash flows and compounded interest rates taken from the book, particularly problems 26 and 27 on page 98. So the problems we're going to be working are making reference to section 2.4.1. Everything is on page 98. Well, it starts on page 98. So the first problem we're going to be working is problem 26. And I'm going to read it. Emma loans Austin $25,000 with interest compounded at the rate of 8% per year. How much will Austin owe Emma if he pays the loan at the end of 5 years? So we need to extract the data from the problem statement, and the parameters that we have is, right now we have a present value of $25,000, which is the amount to be loaned, and the period is 5 years. We have 5 years to pay back the loan, and the interest rate is 8% per year. From the perspective of Emma, since she is lending the money, she's letting Austin have a loan of $25,000. So from her perspective, $25,000 were out of her own availability in the first at the beginning of the period. That's at time equals 1, and then after 5 periods, this is the line of time. On the 5th period, she would get back a future value which we don't know. So the expression that defines the future value that we are interested in finding could be written as the future value is equal to $25,000 times F given P for 8% and 5 periods. That is, the future value that we will find is $25,000 times 1.08 to the 5th, or the future value is $25,000 times 1.4693 to 8077. You don't need always to have these many digits. It's always a concern for the student. Maybe all you need is 5 digits would be probably enough. In this example, the result is $36,733.20. So from the statement of the problem, you can gather the data, and the diagram is always helpful, and the rest of it is just getting familiar with your formulas. This short formula, F given P for 8% and 5 periods, that is always going to be related to 1 plus the interest rate raised to the n in our problems. So once you get familiar with that, and since you're moving or you're computing the value of the money from the present into the future, that's how you do it. Okay, we're going to continue now with problem 27. This is problem 27, and I'm reading problem 27. Charlotte wishes to accumulate $100,000 in a savings account in 10 years. If she wishes to make a single deposit today and the bank pays 4% compounded annually on deposits of this size, how much should Charlotte deposit into the account? Okay, so from the problem statement we can gather a few facts. She wants to have in the future $100,000. The interest rate that the bank is paying is 4% per period, and the number of periods that she's willing to wait to collect those 100,000 is 10 years. So, and the question is, how much should be deposited today? That is, how much should be deposited in the present? A diagram that represents this is, we don't know today how much should be deposited. However, we know that this is today. We know that in 10 periods, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 periods from today, we want, or she wants to have $100,000. And the interest rate being 4%, that means that a future value of $100,000 will allow me to compute a present value, because I know this future value, if the interest rate is 4% and the number of periods is 10. So with this I would compute a present value. That means that this present value is going to be $100,000 times P given F. The factor is 1.04 raised to the negative 10, and this translates to $100,000 times 0.67 5564. In other words, and I could have more digits, but this the result turns out to be $67,556 and 42 cents, and that's the answer. So we can go back and forth with the value of time. If we want to compute the present value, it's a value that happened before that sum of the value we're making reference to. So those were problems 26 and 27. Please follow the next videos to have more examples on how to solve these problems.